So thank you to everybody for joining this virtual Hyperledger meetup today. We have Matthew Whitehead, principal engineer from Kaleido, also active Hyperledger Besu community member. He is going to today share about running Hyperledger Besu in the enterprise, what's new and what's next. And again, as we were saying, we want your input, thoughts, questions. So feel free to share those with us on the Zoom chat. And we looking forward to the discussion. With that, why don't you take it away, Matt?
Great, thank you, David. So welcome to this webinar on Hyperledger Besu. I'll skip straight to the About Me page. As David says, I'm a principal engineer at Kaleido. I'm in Kaleido's UK office in the south of the UK, for anyone who's been down towards Southampton in the UK. I'm also a maintainer on the Hyperledger Besu project. And as part of that, I lead the enterprise roadmap that we're going to see in a couple of slides' time. And I work very closely with the rest of the community in terms of how enterprise-oriented features sit alongside public chain-oriented features. I've been in the IT industry generally for over 20 years, almost all of that working in the space of enterprise software, transactional software. I've spent quite a lot of time working on things which manage transactions reliably, put it that way. Just a moment to talk about the relationship between Hyperledger Besu and Kaleido. Kaleido has a long-standing history with both Hyperledger and Consensus, who lead the Besu project, and Besu itself. So for the last at least 5 or 6 years, Kaleido has been offering hosted Besu solutions for enterprises who want to run Besu chains in a way that is a kind of a managed experience, highly available, highly performant, typically zero gas fees for most use cases. With all of the monitoring and management that the enterprise users come to expect from managed services. So Kaleido has been running Hyperledger Besu for many years and continues to be actively involved in both running nodes and running chains for enterprises, but also in helping to shape the way that Besu can best meet the requirements and the demands of enterprise users. Kaleido has a wealth of experience, not just with Besu, but with other Ethereum clients, and particularly with the requirements that enterprises have, as opposed to the user who might be standing up nodes to run as part of the public Ethereum chain. Kaleido brings a whole amount of knowledge and experience of real world enterprise use cases and kind of feeds that back into the Hyperledger Besu community and product. So you get this nice cycle of Kaleido and Besu working together to make Besu the best possible option for enterprise blockchains. What I'm going to try and do over the course of this webinar is talk through why Hyperledger Besu specifically is a really, really good choice, probably the best choice for running permissioned EVM compatible blockchains. I'm going to talk a bit about the public roadmap, just to kind of familiarize the audience with the way that Besu manages its roadmap for what's now and what's next, and then what's kind of future, and then focus specifically on what we've been doing in the enterprise space around the Besu roadmap, with some demos, hopefully, of some bits and pieces to kind of break up the session. But I wanted to talk just initially about why Hyperledger Besu really is such a good EVM client for the enterprise. And you might think it's slightly odd that what I've shown on the right is the breakdown of the variety of EVM nodes that are running the public Ethereum chain. But the reason I've put that on the screen is to show that over time, you can see the majority of the nodes currently typically are Geth, or Nethermind, what we've seen over the last few years is that Besu's proportion of the public space is now kind of around the 10% mark. And that's up from probably very low single-digit percentages only a few years ago. But that growth in use of Besu in the public chains actually is driving a lot of development and hardening of all of the core parts of Besu that are applicable to both public and permission chains. So as we see growth in the use of Besu in the public space, we're seeing performance improvements, stability improvements, a growing number of contributors to the project itself, and so on. And that's making Besu a really good base technology to underpin those more specific use cases around permission chains, QBFT chains that are running inside the enterprise with trusted validators, and so on. It's also, I think, particularly beneficial that Besu is an Apache 2 licensed project. So for enterprises, even if you're not in the business of building and packaging software products to release, where things like GPL, LGPL licenses would be particularly problematic, Besu's Apache 2 license is kind of what you consider a very enterprise-friendly license. It allows enterprises to onboard software like Besu and not have to worry about how they're going to use it in the future, how their use of it's going to evolve over time. But actually, they can use it in any way they choose to, and that license is a really good starting point when a business is looking at what kind of EVM software should they be buying into. It's also evolving in terms of how Besu fits into more complicated topologies like the layer 2 space. So we've seen the linear testnet that's been built out by the consensus team, and that's a layer 2 zero knowledge roll-up based layer 2 that's based again on that core Besu technology. So Besu's evolution is not just into the pure the kind of hardened public space or the enterprise permission space, but also into more complex, more involved topologies that involve things like roll-ups and bridges and all of the technologies that those require. Besu also has a really, really long history of permission consensus algorithms. So the majority of nodes that run public nodes, things like Geth particularly, are all focused on working with the public chain, proof of work previously, and now proof of stake, where Besu actually has got quite a long history of integrating some of those enterprise kind of originated consensus algorithms like IBFT, Clique, and now the QBFT, which is the one that we really recommend for enterprise use cases. But because it's a long history, starting from Clique as a kind of development permissioned consensus algorithm through IBFT and hardening into QBFT, Besu now has a lot of experience of running chains with permissioned validators of varying numbers across various kind of styles of deployment. And as part of that, really, if you look into this space, Besu is really the only client that's got a lot of active development, again, from people like myself and organizations like Kaleido, that has a lot of active development in the enterprise space, and has companies like Kaleido providing that feedback and contributing time to improve it through maintainers like me. Besu really is the only EVM client that's being actively developed in that direction, as well as the public space. I should say we talked early on about questions. I'll try and pause occasionally for questions. I'll look in the chat occasionally. I think other people will call out if there are a few questions to look at. So feel free to put questions in the chat in a little while time, or do unmute if you want to ask as we go. So let's talk a bit about the Besu roadmap. This is kind of what might be particularly interesting for an enterprise looking at what's been happening with Besu recently, and which directions is Besu looking to go in, what features is it looking at, what discussions is it having about directions for Besu. So This is what I'm going to spend most of the time on, particularly because there are some interesting new features just recently released. And there are some interesting kind of directions that Besu might go in over the coming 6, 12, 18 months. So the Besu roadmap is totally public, totally open under the Hyperledger Foundation. This screenshot here is taken from a public webpage that anyone can go and see. And as I say, working for Kaleido, I kind of lead the right-hand side of the roadmap, which is the enterprise roadmap. And you'll see a lot of the other maintainers, project leads from Consensus and elsewhere, leading the public roadmap. And you can see as you look down those, if you go to the website, you can see how some of those will be complementary, and some of those will be very specifically in one space or another. Obviously, there are lots of features which are purely for maintaining Besu's kind of maintaining pace with the public Ethereum chain, which just have to be got to. Otherwise, Besu stops being able to operate as a node in that environment. So this roadmap is open for anyone to go and look at. And there are links at the end of the slide deck to things like the public Discord channel, where all of these topics are discussed, and where you'll see links to the monthly contributor calls, where again they're discussed in more detail. So again, I'll keep reiterating through the slides. Besu being a totally open source project, it's run by a whole community of maintainers and is totally open to other members coming to join and participate. So this is a picture of the roadmap, particularly around the public space. And I took this from last year. I just took one from a slide deck last year that I think probably Matt Nelson presented on one of the Besu pitches, just to show you the way that the roadmap kind of pans out over time. And you can see in this public-oriented roadmap, there are lots of features around staking for the proof of stake chain, around the Cancun development to reduce data storage requirements and improve scalability of the public chain, around things like the Shanghai fork to allow proof of stake withdrawals. You can see lots of stuff on here that is largely focused on how Besu is keeping pace with developments in the public chain space. What we now kind of talk about in parallel to that is the Besu roadmap, that the enterprise roadmap. So this is the roadmap that I lead, and again I bring to contributor calls to talk through kind of directions we think Besu could go in. And this has features that are probably going to look much more kind of maybe not familiar, but the kind of things that you might see of perhaps other traditional enterprise software, features that allow you to protect yourself from installing the wrong versions, features that allow you to pre-configure Besu in a way that's much more suitable for kind of an enterprise deployment. And most of the slides here are going to be us talking through some of these recent features, particularly the top box that's kind of labeled Q1. So this quarter of 2024, the latest release, which is just coming out, kind of almost hot off the press, just waiting for the next release candidate just to finish testing. Going to talk mainly about some of those recent features, because they're features that some of them are features that people have been asking, quite a lot about. When are these coming? And then towards the end, I'm going to talk maybe about the bottom box and the top right box, about some of the future things that we're looking at, to kind of, again, give some of the directions to where Besu might go in the enterprise space. I'll just briefly mention that bottom left box, that some of the work that was done in 2023, I think maybe moved along some of the enterprise features or the enterprise shape of Besu a little more, by introducing a few kind of fundamental things which almost put Besu into an enterprise mode from the get-go, particularly a new transaction pool, which this time last year, Besu had one transaction pool. Then a new transaction pool called the layered pool was introduced, which gave you much more control around how many transactions you put into the pool, and how different types of transactions went into different types of the pool, hence the layered kind of description. So what we now have is two transaction pools, and the previous one has kind of been re-engineered or refactored into what we're calling the sequenced pool. And the sequenced pool, and you can choose it. You can see the command line option there that I've put on the slide. The sequenced pool is the one that generally we'd recommend using in the enterprise space. And the reason it's called a sequence pool is because we found a lot of the feedback from enterprise users in terms of transaction processing in an EVM chain. People were looking for more typically FIFO-like first in, first out processing of transactions. That's somewhat different to what you see in the public chain space, where you have a whole kind of crypto economy around, well, my transaction will go ahead of yours, even if I submit it later, because I'm going to offer to pay more. In the enterprise space, those kind of models don't really kind of port across so well. So Besu has now a sequence pool, which is intended to be much more like a first in, first out treatment of transactions, where as transactions come in, they're mined into blocks, and generally speaking, they're going to follow the order that they were submitted into nodes. So that was some of the kind of, maybe you'd call that the groundwork towards the back end of last year. That's now kind of being developed at the beginning of this year. So I'm going to focus really on this top box for the next couple of slides. Then I'll probably, during these bits, I'll switch out to a couple of demos, just again to break up the slides a little bit. And I've got a slide on each of those features really, just to talk through some of the latest things coming in Besu. So first one is the QBFT, which is, again, as I said earlier, the consensus algorithm we tend to recommend for permission chains. Until the release is just coming out, QBFT didn't work with all of the fork milestones that the Ethereum community had kind of agreed upon. Generally speaking, I mentioned Shanghai on the public roadmap slide. Most of the work in Shanghai was around the public chain. So it was part of the Chappella network upgrade that allows, for the first time, anyone who had staked currency to run validators as part of the move to the proof of stake world. It allowed validators to withdraw those stakes for the first time. So that was part of the evolution of the public chain. And again, not something that is typically something that an enterprise environment would worry too much about. And certainly in a lot of cases, you might think that as an enterprise Besu chain user, why do I care about most of these forks? I know that as long as all the nodes running on this blockchain are running at the same fork, which could be as far back as, it could be back to Istanbul or Berlin, as long as they're all on that, then they're all talking the same language. Why would I be worried about moving up to newer forks, particularly because I'm not involved in running public nodes? The reason comes from some forks not only bring in features around the public chain, they also, as we see in the Shanghai fork, they also bring about improvements to the EVM, the virtual machine that runs smart contract code itself. And indeed, the Shanghai fork did exactly that. So the Shanghai fork introduced a new opcode. So for those of you who aren't familiar with kind of CPUs, the CPU runs instructions that you give it, and it has a set finite number of instructions you can give it. The EVM over time evolves as a kind of a virtual machine. And in the Shanghai fork, a new kind of machine instruction, push 0, won't mean a lot to most people, and indeed you don't have to worry about it at all. But it improves the performance of smart contract transactions, and that's why it was introduced. Now, again, you might think, okay, so there's a slight improvement in transaction performance for certain types of transactions, but I'm not too worried about that. Again, as an enterprise user, why should I worry about that? And the reason is really on the right-hand side of this slide, that it's not, as an enterprise user, you're not working in a bubble. You're working with lots of tooling that other communities are building and developing and moving forward. And we have seen exactly this in discussions on Discord. The Solidity compiler once you get to a particular version of that, starts using that new opcode. And that means if you use that compiler version against a chain not running that fork, the contract's not going to be accepted by the chain. And again, think tools like OpenZeppelin, if you use built-in sample contracts that use the version 5 OpenZeppelin samples, that uses the given version of Solidity by default that requires this new opcode. So you get this kind of chain of dependencies that it's kind of unavoidable. That's largely driven probably by your developers and the tooling they're using, and the requirement that then puts on your chain. So I thought I'd skip out here for a second and just show a little bit of that in action. So I have some nodes here. This is the Kaleido platform running some Besu nodes. I have, just to zoom in a little bit, I have a London node, so that's configured at the London fork, and I've not turned on Shanghai for that. I've got a Shanghai node, which is configured for the Shanghai fork. And if I just switch back a second, just to put a bit of context into some of this and talk about the tooling a little. So if we go to the Remix, popular web-based IDE for smart contracts, you can ignore most of what's going on here, but on the right-hand side, we have a load of project templates driven by the OpenZeppelin tooling. So if I decide as a developer, I want to pick an ERC contract from the OpenZeppelin library, I've got a nice example ERC20 token to deploy. I've just come straight to the default options in Remix, and all of a sudden, the options I'm given here, without choosing anything particularly, without saying I want to use the latest and greatest version of OpenZeppelin, I've now been given a contract which has a prereq of the version of Solidity that requires this Shanghai fork, and a lot of these imported dependencies will be exactly the same. So I can't just change this one line here and compile to a different version. I'd have to go and refactor a bunch of the prereq contracts in order to get this to run on a chain that doesn't have Shanghai. So that just to kind of give you an example of why in the real world I might care about this. So I've got these. If I switch back to my nodes, I've got these nodes here running at different versions, and I'll just show you. If I switch to a hard hat development environment, so I have a smart contract here, which is again an ERC20, and because this is my own one, I can decide which Solidity version I'm going to compile against, and I have some configuration. I can close that now. I have some configuration here which just points at the two nodes I just showed you. So I have a network configured in hard hat that's going to point at my London chain, so that doesn't have support. And I've got another network defined which points at my Shanghai chain. And what I'm going to do at the top of this is I'm initially going to use an earlier version that doesn't require Shanghai, and I will do a deploy to the London chain first. So I'm going to just deploy a smart contract to the London chain, and all being well, it's going to recompile some stuff. I'll give that a second. Okay, so we can see that my application has got the nonce for my signing address. It's deployed the contract, and then it's just printed out what's the nonce it's going to use next time. So this is just deploying smart contracts to a regular chain. Now, if I decide I want to move up to a newer version of the compiler, so now I'm going to run with 0.8.20, which is what I'd get if I was using those samples I showed you earlier. And if I run that again, and you can probably just see here that I'm pointing this at my London chain, and then try and deploy that contract. It'll do a bit of recompiling quickly. Okay, so now we get a horrible error. And I've tried to make this big so people can see, but in that means I'm getting a bit of kind of word wrap on my terminal. What you can see here is that there's an error deploying that contract. So I've tried to deploy a contract that uses compiled code that just doesn't work on the chain I've created. I should stress here, the two nodes I've got running exactly the same Besu version. Nothing to do with Besu versions, just the forks that I've configured on those nodes. So exactly the same Besu version under the covers. So what I'll do now is I'll just clear that out. And now I'm going to deploy to Shanghai. Let's do that one there. So now we're going to deploy to the Shanghai demo chain. And yeah, I've done this a few times, so my nonce has gone up from 5 to 6, and you can see that worked absolutely fine. And if I just show, I had some curl requests that just query those chains a little. I can get rid of this code a bit here. So this is a curl request to issue a JSON RPC SQL to ask about the London chain. So we can see that we have the Berlin block on by default. We have the London block, but no Shanghai block here. And then if I do the same against my Shanghai node, we can see this time I've got the Shanghai block. It's actually set as a timestamp now for folks from Shanghai onwards. But we can see that I've got Shanghai enabled for my other node. And if I want to be really kind of show you that exactly what I was saying here, these are exactly the same versions of Besu. This is 24.20. If I go back up, the London one was running exactly the same version. So no difference in versions, just the way I've configured those chains differently. So I hope that was kind of putting a bit of context into some of what I've been talking about in those slides. It's kind of hard to make some of these demos super exciting. So I hope that they're at least adding a bit of context. So let's go back. So that's a feature, the latest version of Besu just coming hot off the press, that has been much asked for, and Besu now supports. I'm just gonna, just before we go on, thanks. I can see that there's some people answering some questions in there. That's much appreciated. I'll come back and look in a moment. So then another feature that Besu now supports comes from some discussions around the fact that Besu has lots of configuration options. And again, and you know, until recently, it didn't really prescribe which options you might want to use in certain environments, particularly. It had the concept of naming a network. So if you configured to the go early test net, it had some pre-configured options for that. That's really around the Genesis configuration. But as a public user and a permissioned enterprise user, your experience of setting up Besu was really similar. You had to pick and choose the options that best suit you. And what we found talking to enterprise users was getting Besu to perform really well and be stable and achieve the kind of SLA requirements they have could involve quite a lot of manually kind of trial and error of how to configure Besu. And indeed, to get a permission chain to work effectively and to be performant, you do need to go through and make careful choices about some of the kind of intricacies of the way that Besu works and the way that Besu nodes talk to each other. So Besu took that on board, and what we have now in the latest version of Besu is a profile option. So that I've put it again down there. It's just a command line option, or you can put it in your config file. And what it does is effectively applies, when you choose your profile, it applies a config file, a TOML file is the way that Besu formats configuration in files. It pre-ships a TOML file for different types of node that you want to run. And Besu now offers 3 or 4 different profiles for different types of node. The 2 main ones I thought I would call out here is that if you are running a public chain or a public node against the public chain, you can choose profile of staker, and that pre-configures a whole bunch of options that are much more suitable to a public node. So I've talked already about the transaction pools. So in a public node, you want the layered transaction pool, which is better suited to handling transactions from a wide variety of different transaction applications. The transaction pool itself is typically going to need to be resilient to the fact that large numbers of applications might submit transactions to it. You might have a large number of transaction accounts, sender accounts, and you probably are conscious of any one account monopolizing your transaction pool. because once the pool is full, it can't accept transactions from other senders. So typically you would tune the pool for that kind of behavior. You might also, if you're running your own node on the public network, what you tend to see for a lot of people running their own nodes is that they give their own transactions priority when the transaction pool is selecting the next ones to use. It's fairly common. It doesn't kind of skip past any of the crypto economics of which transactions, which blocks get mined, but it allows you to prioritize transactions that you yourself have submitted to this node, not transactions that have come in from another Besu node through the peer-to-peer communication of transactions. Again, you probably, if you're running a public node, you want a balance of how many P2P connections your node initiates to other nodes and how many other nodes can initiate to yours. You typically want this to give you a sort of a kind of a denial of service protection from your node being swamped with connections from other nodes, reaching your node's limit of number of connections it wants to maintain. And then the connections it's got to other peers are kind of semi-random, depending on the race to connect to your node when you've joined it into the network. So typically a public node, you want to allow some of that, but you want to reserve a proportion of the number of connections to be ones that you configure, that you control. You might want to connect to particular boot nodes, or you might want to connect to particular other nodes that you're aware of. And public nodes, you would typically see that balance of inbound and outbound connections. And then, of course, the gas price is going to be set by the way that the chain works. On the permission side, we have this profile called enterprise. And the intention of the enterprise profile is to give you a good, pretty performant, very stable Besu node for the kind of scenarios we have seen in enterprise use cases. So we picked the sequence transaction pool by default. I talked about that being the one we recommend. And so that one's picked by default if you choose this profile. The transaction pool is configured to, by default, allow many more transactions from one sender. So again, typically we would see for very high performance environments, people perhaps using the same sending account to drive a lot of transaction traffic into the transaction pool. And the only way you can do that if you've allowed an individual sender to use a lot of the pool. If you haven't, then that sender gets stuck after, say, 5 transactions, and it can't get the 6th one into the pool until the other ones have gone into a block. So what we configure by default is that any one sender can have much more of the pool, of the order of hundreds by default, out of the kind of the few thousand that typically it's configured with. Again, if you're running permission nodes where the nodes are kind of acting as infrastructure as part of the rest of the infrastructure in your IT network, what we have tended to find is enterprises don't want the order of transaction selection to be based on where an application happened to connect. If the application connects into this node or this node or this node, you just want the transactions to be prioritized roughly evenly. You might be load balancing across them. You might have some other kind of components in the way. And there's no real need in an enterprise for any one node to say, the transactions I receive are much more important. You can manage that in other ways. So typically that's the behavior we see people using. And so that's the default for the enterprise profile. And also, again, because all of the peers are typically trusted, because the number of them is not going to be the same order of magnitude of a public chain, typically. And because you know that really, if you're creating a kind of a mesh network, which a lot of users are, you want all your nodes to be connected to everyone else. The order that those connections happen in is not really important. And what we saw, if you didn't set that, is you could get nodes only having half the number of nodes it should have, because just by total coincidence of the timing of when connections were initiated. So the default for the enterprise node is that it doesn't matter which order nodes try and connect to each other, they all end up as peers. And then finally, the obvious enterprise use case is that gas is free. So gas is set to a minimum price of 0. It's worth saying that all of this is just about setting up initial defaults, setting up good good settings for a lot of typical use cases. It doesn't prevent you then setting any number of other configuration options you want, and your options take precedent. So if you want the enterprise profile, but you want a gas price of 100, then you can set that. Or if you want the enterprise profile, but you want to tune the transaction pool in a slightly different way, that's totally fine. It doesn't mean you have to totally switch off the profile and go and set everything manually. You set the profile to enterprise, and then you go and add and tweak the particular settings that are relevant for your environment. And then another feature that's just coming out in the latest version is, again, a lot of these are driven by real world kind of use cases we've seen. When it comes to actually consuming software, we've moved out of the world where you have an operating system installer, maybe a person manually running an installer, and that operating system maintaining information about the versions of particular software you have. We've moved kind of away from that. We tend to see DevOps, GitOps being the way that people are managing their infrastructure software. What you particularly don't want to have in the case of blockchains, like anything like a messaging system or a database system, the integrity of the data is really, really crucial to your business. And in most cases, it's very unlikely that what you're going to want to do is downgrade the version of some software, and run the risk that that might not be supported between particular versions. It might not be the case that any given version of Besu is guaranteed to run correctly against a previous version. And because the number of cases you might have of wanting to downgrade are much fewer than the protection you desire over accidentally corrupting your own data, what Besu has added in the latest release is some protection to avoid doing that. This protection is kind of a level up from the storage component in Besu. So Besu has its own database component, and in that, there is additional protection. But crucially, the database component in Besu is pluggable. So if someone plugs their own database solution in, they're going to have to remember to manage data integrity, backwards compatibility, preventing downgrades that are going to break data, and so on. So Besu has looked at that and said, we're going to have a layer above that. We're going to have just a fundamental version compatibility check. It doesn't matter if downgrade would work. By default, in the case of non-named networks, basically permissioned networks, by default, if Besu starts and it detects that the version it's starting at is earlier than the last version to use that data directory, it will fail to start, which is much more preferable to starting and potentially corrupting some data. So this option, as I say, it's on by default if you're using a non-named network, which most enterprise users will be. It basically means that if you're specifying your own Genesis file, you'll get this on by default. If you want to make sure it absolutely is on, you can set this version compatibility flag to true. And if for any reason you do want to do a downgrade, you can set this to false and it won't apply these checks. But as you can see here, what it can allow is that slow and steady upgrading of Besu. If it hits a point where it detects a downgrade, it fails to start very early on. Obviously, this has to happen very early on in Besu's startup process, well before it's starting to interact with data. So very early on, it will perform this check. And again, I'm just going to jump out for a second just to show a little bit of this working in action. Again, I know this can be a little dry, some of this, but I think it's really useful for people to see this in action, how it's going to protect their enterprise networks from this kind of issue. So I've got a node here. I created it here and I just called it no downgrade node. All of these are no downgrade because they're using the new version of Besu with this protection, but I thought I'd create one that I can go and hack around with and play about with for the demo. So this is the data directory for the Besu node that I showed you there. Happens to be running in a pod, but that's not particularly relevant, although, you know, it kind of talks to the fact that that kind of movement to GitOps and DevOps is real. So what you see in here now is this file, which is called the version metadata.json file. If I look in there, we can see that what Besu has done when it started up, it recorded its own version in here as the means to apply that downgrade protection. Now, in order to demonstrate this, Besu has only just added this feature. So I can't show you two different versions easily without kind of playing about under the covers a little bit, because there isn't a second version to kind of show this downgrade protection working. But what I'm going to do is I'm just going to edit this to show you how this works in action. And I'm going to pretend that Besu was running at this later version, 24.3. At some point, Besu will release this, but I'm going to pretend Besu started at 24.3. And remember, I'm running 24.2. So Besu started at 24.3. And then I'm going to just delete that pod. So I'm going to delete that pod. And so Besu, which is running at 24.2, is going to restart. Just watch that happen in a second. So Besu is now restarting. I've made this too big. I've got some horrible word wrap. So Besu is now restarting at 24.2, but I have edited the protection file to pretend that previously it started at 24.3. We're just going to now look at the logs for that node. And we're going to watch Besu start up. Here's Besu, it's starting up. And it's basically, it's just quit. In this particular case, it's going to go around in circles because this particular pod is designed to kind of restart it, but I'm gonna kill that now. We're just going to go back up to where Besu started. If you're familiar with Besu starting, this is the kind of the header that you get printed out as it starts. It shows you the version it's running on. And you can see I've got some of those enterprise features that we talked about. I've got this sequence transaction pool and so on. And as we scroll down here, we can start to see Besu is performing some of these version checks on startup. Again, some of the first lines you see in the log here. So we can see it's looking up the version. It's checking that an existing version file was found. Again, I'm trying to make this big enough for people to see, but not so that we get a horrible line wrap too much. Just go down a little more. Okay, that's probably good enough. So we can see that Besu's detected a version had been started, and it knew that it was 24.3. It knows that it's starting at 24.2, and it knows that's lower than 24.3. And what it's going to do now is basically crash out. So if I was running this outside of a container, it would just quit back to the command line. In this particular case, the pod will just occasionally restart it, and you'd see this cycling. But what won't happen is Besu won't start and start using that data directory. It's just going to keep looping around, rejecting the fact that it's now trying to start against the wrong version. And that will just loop around and give you that protection around some issue in your pipeline, some error in a command you ran, some error in tagging an image incorrectly that meant you pulled a version of Besu you thought was at one version, was it a different version, anything like that. Besu will now self-protect against that. And it'll self-protect even if you're not running, in things like containers. It's going to apply this protection. And if you really want to downgrade to a given version, if the data isn't particularly if it isn't production data, or if you've tested it and you're happy the downgrade's going to work, you can remove this option and say, no, it's fine, do the downgrade. And what Besu will do is then it'll downgrade anyway. It will remark the file as being at that lower version, which means from then on, it thinks that's its starting point again for future checks. So again, I know that lots of staring at a terminal window during a demo is not the most exciting, but I really wanted to kind of get across some of the context of these features and the extra protection they're adding in kind of real deployment situations. Okay, so I'm going to pause there. That feels like a good point just to see if there are any questions. Please feel free to come off mute if you want to ask any. I can see Jim has very, very nicely been answering some of those. Any other questions before I just move on to the last kind of 15 or 20 minutes. Okay, so I'm going to carry on. I think, yeah, we're probably going to run to about an hour, maybe 5 minutes over. And I'm going to be here for a little while afterwards if there are questions after we finish the slide deck. This last part of the presentation is thinking a bit about what's coming next for Besu. So we've seen some really good development of Besu in terms of how good a fit it is for the enterprise. And what we are now kind of moving on to is, okay, so what's next? What are the things that continue to evolve Besu and make it the best solution for enterprise blockchains? I've got some slides on like two of these particularly. So I'm going to call out two of these specifically. One is kind of maybe in the nearer future, and one is a little more kind of having some slightly long-term thoughts about ideas. But I'm just going to whiz down some of the ones on this chart because I haven't put slides for all of these things, just to give you some idea of what's being looked at. So currently being kind of worked on is support for empty block periods. So if you have a block period of 2 seconds, but you have a period of the day where no transactions are submitted, then empty block periods will give you the ability to decide, well, how often do I want a new block if there are no transactions? If I can reduce that from 2 seconds to 20 seconds or a minute, then I can reduce the amount of storage, wasted storage, that's unnecessary when no transaction traffic is going through the chain. Because remember, even if you don't have transactions, if you're mining blocks, those blocks will need to be chained in, and you're slowly increasing your storage requirements. So something that's being worked on is support to be able to configure a block period that will apply if no transactions are present at that point in time. Another area that's kind of being discussed, looked at, worked on is QBFT's recovery behavior. And this is something I do have some slides on, but this is around in an enterprise world where an outage needs recovering from as quickly as possible. The behavior, the kind of nuances of the way these consensus algorithms work means that the default behavior you get is kind of not what you would typically be looking for as an enterprise user. And again, I'll talk that through in a couple of slides. Support for QBFT and SnapSync is being worked on. So SnapSync is the preferred way for a public node to get the world state, the picture of the world state from its peers in as efficient a way as possible when a new node is being created. So a new node requires all the historic blocks, which it's going to ask peers for, but it also needs a picture of the current state. And what it doesn't necessarily want to do is start from block 0 and rebuild state a block at a time, which is what you would get if you used full sync today. So SnapSync is the way that really Besu is going to be moving in terms of the preferred syncing mechanism. The problem is that in a permission chain, for SnapSync to work, you have to have a node that knows how to serve up SnapSync data. And currently in the public chain space, Besu can consume SnapSync data, but it can't provide it. So that's something that this is an area of development which is kind of both public and permissioned development. The public side of Besu really needs to add support to serve up SnapSync data because it needs to be a good citizen as part of the Ethereum network. But in a permission chain, any node that wants to consume SnapSync data, it needs to ask someone for SnapSync data. And currently, because Besu doesn't support serving up SnapSync data, it's got no one to ask if it's a Besu chain. So SnapSync support will be coming. Once that comes, support for running a QBFT chain with SnapSync, which is going to make it much more efficient if you want to add a node in the future and you're 10 million blocks into your blockchain. That's going to make it much easier to start onboarding new nodes as your network grows and so on. And in slightly future, the Bonsai database again, this is an area that Besu is moving in terms of the way that data is stored. And again, the preferred option for storing data in Besu, again, in the latest release, has just moved to Bonsai by default. But the way that Bonsai works, again, is really good for public chains, but if it doesn't, it's not a good fit for an environment where you want to query an arbitrary snapshot of the world state at an arbitrary period in time. Typically in public nodes, you don't really need to do that very often. But in an enterprise setting, you might have archive kind of requirements to access historic data. Or you might have reasons to go and query what was the state at a given point in time, 10,000 blocks ago or 1,000,000 blocks ago. So with the forest database and the full sync mode with Besu, you can do that with a kubeft chain, but it means you're storing an awful lot of data. Bonsai will improve that, and Bonsai will become, I think, the preferred option for kubeft chains at some point in the future. Remember, it's now the default for Besu, but for kubeft chains, it probably needs to remain forest. However, the ability to move to Bonsai for a permission chain really relies on the ability to have some more archive features that give you the equivalent of querying world state at a given point in history. So that ability to do archive-like queries, but on a Bonsai database, again, that's being worked on, that's coming. And I'm hoping we'll see over the coming 12 months that comes along. And then there are kind of general thoughts around things that we might look at. Can we make nodes more highly available? I've got some slides on that. Maybe block exports for backup could be automated, so I don't have to do that manually myself and stop the node in order to do it. Maybe some performance tuning recommendations for really pushing performance, not just to good, but to really, really driving high loads of traffic through. We'll see. So last couple of slides are just going to talk about two of those in a smidge more detail. So kubeft recovery behavior, and the reason this is relevant is because the recovery time, if you have an outage of validators, can be surprising. So I've got a couple of slides which explain that and talk about why this is something Besu needs to look at. So let's say I've got a healthy chain on the left and all the validator nodes are at this block. I've tried to make it obvious that use sensible numbers so you can see this block number is not going to change over the next kind of slide or two. So we've got this block 1, 2, 2, 2, 3, 3, 3, and they're all at that. And two of the validators go offline. And if you remember back to kubeft consensus algorithms, you need a supermajority of those in order to mine blocks. So with two validators gone, the remaining two validators can't mine blocks. So again, this chain is stalled. No new blocks are going to be created. However, the nature of kubeft is that the validators will, over time, try and move the kubeft round along after a given interval. Moving the round along progresses the validator that is allowed to propose the next block. So kubeft is designed to just slowly bump this up one at a time and effectively move through the validators in case it finds a round that means enough active validators can now, firstly, one can propose a block and that there are enough other ones to mine that block. So what happens is you get this kind of toing and froing where the remaining validators are going to propose a new round. It's going to go kind of 0, 1, and then there'll be a bit of a delay, and then 2, and then a longer delay, and the delays are going to get bigger here. So the proposing round 3 might be twice as long as proposing round 2, proposing round 4, twice as long again, and so on. So what you see is these two validators, they slow down because they don't want to increase the round time in a linear fashion. And that's kind of fine until you get to looking at what happens when we bring these two validators back online. Is the chain going to start mining blocks straight away? The answer is absolutely not. So let's say we've hit a point where we're about to restore these validators, and the two that were online are now up to round 6 and 7, and we're talking now minutes between the rounds being proposed. Why is that relevant? Well, let's look at the right-hand picture, and we brought the two validators back online, and they're going to start, they technically start at 0, but I just thought I'd do this starting from 1s. They're going to start from one, and they're going to propose that they think we should be on round one. And the agreement between these for the QBFT algorithm is that they have to have a quorum of agreement on what the next round is. So the two validators proposing one, they can't agree because there aren't enough other validators proposing it, and they can't accept the other round nominations. And I guess what I'm trying to say is it takes a number of minutes proportional to the outage for the validators to come to an agreement on the next round and mine a new block. So what we have here is finally we have a new block. 11112223334. If those two validators are down for X minutes, whatever the value of X is, for the period of time that the two validators are unavailable, the period of time for the active validators, once they're restored, to mine a block is proportional to X minutes. So if I have an outage for 5 minutes and I bring the validators back online, I'm not getting a new block for 5 minutes. If I have an outage for 10 minutes, I'm not getting a new block for 10 minutes. This is a really kind of important aspect of QBFT that it's not totally obvious. If you have an outage for 10 seconds, you're probably not going to notice this has happened. But if you have an outage of many minutes, and you restore your validators and you think everything's fine, everything is going to crack on and start mining blocks again, the period of time to mine a new block is proportional to the time that the outage occurred for. And in an enterprise setting, so the fix for this, the skip to, okay, what's the fix for this? The fix for this is you restart your validators. You go around, you stop them all, and they start at zero again, and then they quickly restart. That's today's solution to this problem. And I think where Besu needs to go is saying, well, that's not really what an enterprise environment really can live with. Always restarting everything when there's some downtime. And I think there are some interesting things that the Besu community could look at in terms of making that a much more acceptable kind of recovery time, an RTO, return to operation time, a much more acceptable time than the current behavior, which has that link between the outage time and the recovery time. So that's one area that I think Besu probably needs to spend some time kind of looking at. And I think other nodes do have a slightly improved behavior over this. They do have a slightly more lenient kind of progression through the QBFT rounds. So one step will probably be Besu looking at whether it can just adopt that. But I think there are other options around. Can it be better than that? Are there cases where it can be more pragmatic? And enterprise blockchains are often about, I want a blockchain, but maybe I have a few pragmatic decisions I can make, which don't compromise the security. They don't compromise the Byzantine fault tolerance, but they might just be kind of some pragmatic tweaks that allow me to have a much healthier bit of infrastructure for my applications. Okay, then lastly, this is again maybe much further down the line, kind of looking at things, thinking about things, working out what options Besu might have. This is go back to my favorite picture. You see this picture in lots of the slides I draw about blockchains, just blue blobs being validators. So in the case we've got 4 validators, and we've seen a picture just a minute ago where 2 go offline. If those 2 go offline, as we know, we haven't got enough validators to mine blocks. So what could Besu be doing to improve this just generally? What fundamental architectural changes or options could Besu be looking at? So one kind of thought process / discussion is to look at options where maybe there might be ways of running more than one instance of a given validator. Maybe I can have distributed validators where I can tolerate an outage much better. My SLA, my kind of ability to keep mining blocks and keep mining transactions into blocks is much better, even in quite dramatic outage scenarios. And these are kind of some of the thoughts that, again, if you're looking at the requirements enterprises have for their SLAs, for their return to operation times, um, whether or not blockchains based on things like QBFT can meet those is an area that is, I think, still, we know we can in certain topologies. Can we do that and be more resilient? Can we do it in other topologies? Can we do some really quite interesting things that actually make a blockchain and its validators much more clever and able to withstand particular types of outage. So again, this is more in the kind of looking at options, having a think about where is a little way down the road. But I think it's really useful to talk about it, particularly on these to these audiences around. We're spending a lot of time thinking about really difficult things, really difficult enterprise scenarios. And the intent is to feed all of that back and just grow Besu's ability to be the right fit for the enterprise. Okay, so that is the end of pretty much most of the content. I want to just kind of recap. So currently, Kaleido is driving this enterprise roadmap. And I, as a maintainer on the Besu community, am very hands-on keyboard, put it that way, very hands-on with exploring some of these things, fixing things, working on features. And you'll see me on Discord, and you're very welcome to reach out to me directly on email or through Discord. And I'd welcome anyone who wants to come and discuss some of the things we've talked about here. And again, as you've seen, I did all my demos running Besu on the Kaleido platform, running nodes with various configurations, all highly available and highly performant. And that's a service that Kaleido brings to this space. Please come and find Besu, both on Discord, GitHub, and so on. And then that's just some links, some Kaleido links and things, if you're interested in trying some of the platform that I showed as part of the demos. Okay, David and/or Kevin, I guess. I think that's pretty much me done. I'm just looking on the chat for any other questions I might have answered, but also I'd like to reiterate, if anyone wants to come off mute and ask about any of those things, please do feel free now. David, I don't know. If you, I just want to check I can actually hear if anyone's saying anything because my volume's up. Are you about now?
Yeah, sorry, I was on another. I had another conflict for another call
No
for
problem.
minutes.
No, I just wanted to check I wasn't missing people coming off mute because my volume was down or something.
Oh, got it. I don't think so. And I'm checking on YouTube. I see people watching, but I don't see anybody asking questions over there.
I'm very happy to stay online on the live stream for a little while. Oh, there is a raised hand.
Yeah,
Jim,
I see it. Yeah, somebody just raised a hand.
do you want to come off mute, Jim?
Hi. Yeah, thanks for the session. It really was a great session to sort of move me forward rapidly into where the current world of Besu is and where it's headed, which is a really wonderful thing. And I hate to say it, but I could care less about the public network, honestly, only because the enterprise can support both public and private. And somehow that message completely gets lost to the entire DeFi community. So they have no understanding of this. But I'll introduce an interesting concept. You're familiar with zero trust, right?
Yes, yeah.
Okay, so there's a new concept. So you're familiar with the Facebook outage, right?
A little. You might have to refresh my memory a little.
Well, the recent one this week, they had a serious outage on Facebook and WhatsApp and some other stuff that didn't affect the entire network, but it was significant. It was like whatever it was, 40–50% of the users were unable to access the network, right? But I came up with a sort of an enhanced concept, I'll call it. It's called BZFT, which is below zero trust. And so that's where you don't trust the zero trust network itself. And so, which is an interesting thing that in a sense, I'll flip it out there and say that's a pattern in a sense that you'll be thinking about going forward, I'm sure. That said, when I look at the enterprise side, the one thing on QBFT, and you've already hit this in your planning roadmap for Besu. There's a wide spread of different application use cases for enterprise blockchain, very wide. And the more you touch it, the more you find it opens up. And what you really find is that, in a sense, one model or one pattern for any of this never works. And I will say the public side of Ethereum, while to Vitaly's credit, he's the one seems to be driving the enhancements there with the EIPs on the public side, which I very much appreciate that. In reality, the public side will always be incredibly limited. And what's interesting is on your end, as the lead, and I'll say Kaleido collectively the lead on the architecture for Besu enterprise networks based on EVM, which is not potentially it's a very good thing. The challenge of it's going to be that to support those wide, very wide use cases, you're going to wind up having to, in a sense, do what you have already started to do, which is create what I call multiple architectural options and patterns within frameworks. And I suspect, picking on Kaleido, you guys are going to unfortunately have to be what I call the lead. It's not that you're the only, but you're probably going to be what I call the architectural lead for the community, if you will, moving in that way, big time. And I don't expect that what I call the old style DeFi stuff sitting in the old crypto world will even have an understanding of what these use cases are. So what that means is when you look at something like a consensus algorithm like QBFT, what you're really saying is, no. We have a different concept of what a transaction is. And something like QBFT as a consensus model is just one consensus model. What you really need is that consensus interface, much like you do in Firefly, and say there's an interface here, and you're actually free to swap, if you will, different consensus algorithms back to your point, which you've already done very well, like other software, advanced software with a profile concept. So you can say, okay, for this use case, Jim, if you're going to do very high transaction volumes, then QBFT is not an appropriate consensus method. And we have a different architecture for that stuff. So I would argue, because I've looked at, I was working off of what I call Fabric, trying to drive it to a different place. But I think you're in the same boat with Besu and EVM saying, okay, it is a private EVM network. And in this private EVM network, this particular use case, I'll need to get to the capability of 500,000 transactions a second. And what that really means is it's not just the consensus method that's different. It's even what we call the life cycle. And the assets are all going to change as well. So there's going to be some significant, what I call, and you're already doing it nicely, I think, as a process, but there'll be a continued evolution of what I call the rethinking of what a transaction lifecycle really means. And so, one of the biggest areas that I came up with was the difference between something which actually advanced databases like telco databases based on MySQL already have these. I invent nothing. I just steal from other people. And so MySQL already has this, which is pretty elegant, but they have a separate concept between, for a transaction between commit and finalization. And so I think in your world, those kind of concepts are going to have to come into play for sure to get the kind of scale for certain use cases that, in a sense, your model and your architecture is going to need to support.
Yeah, all very good points, Jim. Really, really interesting points. And I think you're right. I mean, I think your general point of it's an environment that's in flux, and that there's the space is going to evolve even more than it has been is certainly true. I think the things that are most interesting around some of the things you talked about are what is a transaction like when you have multiple chains? So you have discrete chains for certain things, but you have bridging or rolling up between them. What's your measure of what a transaction is in that world? And also just to touch on, you mentioned the kind of the pluggability of consensus and things. I actually on another slide deck I talk a little bit about just how pluggable Besu is, and pluggability of the consensus algorithm already kind of sort of happened with the proof of stake side of things, where the engine API means you have Besu not doing the consensus part, but handing that off to another process, and you have this kind of IPC between the two. And there has been talk around some of the permissioned, well, all of the permission consensus algorithms don't use that model, and they're not kind of pluggable components. They're baked into the Besu code base. But making that an additional point of pluggability has certainly been discussed. And I think some of the things you mentioned, good arguments for where maybe more of Besu could be pluggable. Even though quite a lot of it is that I mentioned the database layer is already implemented as a plugin in using Besu's own plugin architecture. I think Besu would like to become more, the discussion topic tends to be about modularity. We'd like to be more modular, allow third parties to build on their own at their own cadence, and allow you to plug in many more of the core capabilities of Besu, of which obviously consensus is a really, really big one. Yeah, really good points. Thank you, Jim.
Thank you.
Any other questions people want to come off mute to talk about, or comments or feedback or thoughts?
Yeah, I'm not seeing any questions coming in on YouTube, and I don't see any other questions in the Zoom chat.
Yeah, no, agreed. Yeah, I think that's everyone. Yeah, I can't see any others on the chat. And thank you to anyone saying thank you on the chat. Really appreciate it.
Yeah, thanks for sure, man. And thanks to everybody who dialed in. And hopefully this is the start of a conversation. If you're interested in Besu, yeah, definitely join us in the different channels, and we'd love to keep having the discussion with you. Great. Well, if we're all set, thanks everyone for dialing in.
Thank you, David.
All
Thanks,
right.
everyone.
Bye, everyone.